To see if two floating numbers are the same or not, for equality, you should not use equal, but you should just take the difference. If the difference is small enough, you should consider them equal. So for doing so, let's make a helper method for that. Public static boolean, we are going to get true or false is equal, and the floating point number, two numbers are provided. Then the idea is here is that take the difference, so which means we have absolute of x and y, and then if absolute is a smaller than some very small number, then we consider x and y are equal. So absolute function is there. So math has a ABS absolute function. So take subtraction of x and y, but absolute, so ignores the sign. So that is the difference. If the difference is small enough, some small number, then we say that is equal. Otherwise, we say that is not equal. So that's the idea. Then how small is good enough? It depends on your application program domain. For example, if you are comparing two floating numbers and each number is for money value, like whole part is dollar and then fraction part is cents, then you can define small enough something like this. So final int small enough is if the difference is like this small floating point number, then float. Then this is small enough to compare two money values. You know that up to here is just cents, but there is a gas station. The gas is sold 1/10 of cents is also part of the value as well. So if you take this number, then any two money values difference is smaller than this, so we can just consider they are the same. So based on the application domain, you can define how small is small enough. For our case, let me just give a very small tiny number. We are comparing two floating numbers in shape representation, x location, y location, and area and the like. Then what you need to do here is something like this. We should do assert is equal. So this is the first floating number, and what you expect is this is a second floating point number, suffix f is required. Then we are checking difference against this one so that it will return okay or not. As I run it, there is no assertion failure and the like. So also you can check get area, and an area we expect is 2 is a radius. So what you expect is 2 times 2 times math pi, and then we need to pass a floating number there. Then as we run, no assertion error occurs. So using this mechanism or utilizing is a equal method, so you can compare equality for two floating point numbers, and using this you can make automated test assertion fail or not instead of visually checking the results.